Okay, making a new movie because I'm streamlining the process compared to last year. And this is weird. I totally get it. But please understand that this is it, by the way. Tomorrow I just have planned that you are going to break down one question through some sort of process I'll organize. Then Monday I'll just have the standard review, and then Tuesday we'll just quiz on this chapter and move on. I do get it. I've also often said this is probably, of all the chapters that we do, this is maybe not my favorite, but now I'm kind of liking it more because of the whole idea of a project manager that probably people have in many businesses, and the whole idea of optimization compared to our last chapter, optimization in traveling, based off of your college project. So we're going to keep it short, just so you know the ideas out there. I know some people, first hour we got into a discussion about like this compared to stats, and someone said at least stats was math, and I get it. Some of the things we're doing is weird, like today we're going to make a pizza. You walk out of here being hungry. But it's the spirit of the idea. When you get these tasks and get the precedence relations, we're just trying to keep it simple with the silly examples. So if you could just buy it for a little bit and get the spirit of it, that would be good. That's all I'm asking, like Ange. So what I'm changing from last year's movie is less words. The words don't always work. When I try to give you do this step 1, do this step 2, do this step 3, it doesn't translate very well to the question. So what we're going to do is make a Gantt chart, and there's more than this. There's actually a section 7.3. Just like I said in last chapter, there was more than the repetitive nearest neighbor test. There was more, but just to give you an idea. So to make a Gantt chart, we can do either an increasing time priority list or a decreasing time priority list, and that's all we're going to ask you. I don't even know what 7.3 says. There's another one. I forgot the name of it. I read it this morning. But you need to know what a Gantt chart is. So here's at least the words of it, and then really what you need to do is emulate what I do when I make a Gantt chart. And it is a diagram. It will kind of look like what the lady showed you in that video. There's bars. I'd like to see the video again if there was a time element as a scale on the bottom. And those represent people working on a task. So it's a diagram that keeps track of the order in which tasks are done and how much time elapses while they are doing it. And it's based off of the digraph and priority list, and this is what you did yesterday. From a chart, you made a digraph, you made a priority list, and then you found the best one. Like the maximum time is the minimum that the job could get done. We'll make sure we say that in the movie later. Did I just hit play? Whoops. Okay. All right. Now, last year's notes, if you watch the video, I'm pulling it forever and putting this one in its place. Shows 5 steps of how to do this. We're not doing it. Do this. Write down this. We're going to make some pizza today. Yay! I love math. And then I'll tell you, step 1 and step 2 are what you did yesterday. Step 1 is and don't go ahead and do step 1, but I'm going to turn off my voice as my students write this down. And then just the spirit of it. I know no one would ever do this before they make pizza. Just do it. Okay, I'll keep blabbering. I was thinking of saying this offline, but keep writing. When it comes to the quiz on Tuesday, I'm going to have you do 2 things. I'm going to have you do yesterday's stuff. So from reading this, you do have to make a digraph with the precedence relations. So as you're reading this, you have to see, who do I have to do before I do something else? Are some of these tasks independent? And then you have to make a digraph from it. And then from that digraph, find the critical path, which creates the critical time. But then if you got that wrong, would you be able to make a Gantt chart correctly? No. So I have another question with a new graph not tied to this, and then you make a Gantt chart using either the increasing or decreasing priority list thing. So I thought I'd say that real quick because it is problematic. If you get the first part wrong, then you're all wrong. So Common Core in this out, having my students, whether they're doing it or not, locate all the sources and sinks. So really, how do you find sources? They're the beginning, and anything that kind of is an independent from something else is probably a source. By the way, what's the only sink? There's only one sink in this question. Bake the pizza, so everything is going to link up to this at the end. That's what a sink is. That's their term. Someone looking at me cross-eyed. But that's, if you weren't here, you should have watched the video. But just Mr. Samuelis saying his thing about how people are successful. Sorry. Is number one a source, yes or no, class? Well, darn right. And usually it is the case, like the first thing listed. So rolling and making the dough. Is grating the cheese dependent upon rolling the dough, or could I grate the cheese first? So is that a source? It's an independent task. That's a starting thing. Doesn't say take the cheese out of the refrigerator. Then that would be the source to grating the cheese, right? What about slicing the pepperoni? Source? Okay, because it's independent. I could work in any of these three. I could start any one of them. What about adding the sauce? No, you'd have to do this first, then that, and then that tells you how this is going to be linked up on your graph over there. What, what about adding the cheese? So what usually goes first? Sauce, then cheese, right? So wouldn't you agree that this kind of has to go this to that, right? And then this tells you how this graph is going to be over here. What about adding the pepperoni? Now we can argue. We can definitely argue. Who puts their pepperoni on top of the cheese? How many people? Raise your hand. Isn't that the majority? I guess if you had these flipped. All right. Okay, so we do have a link here, but then you do know that this also is part of putting the toppings on. So, yeah, definitely slicing it first, then I'm going to sneeze. Uh-oh. And then add the pepperoni. So something's going on there. And then what about turning on the oven? Shh, silence. Huh? Oh, yeah, so we'll have some connection there too. All right? Right. You're right. I kind of made a mistake there, and then this is how this is going to be. Then what about turning on the oven? Is that a source or not? That has nothing to do with anything else. It's not isolated, though, because it's connected to baking. What you do, and you do need this graph, all right, in order to be able to do the next steps. So I think we agree that rolling the dough, T1, and then now that we learned, we put the minutes in there because we need this in order to do our next thing. And then, what was rolling the dough connected to? You roll the dough first, then you add the sauce. And the arrows mean which order you're going. And that's 5 minutes in T4. I'm going to go slow because it should be. Keeping up makes this happen. Then add the cheese. And I think everyone would agree that you'd put sauce first, then cheese. Isn't this great? Is this math? 4 minutes. First I worked out angry. This isn't even math. I wish we were doing stats. All right? And then add the pepperoni. Do you really wish you were doing stats? I'll bust out the book if you want to. It's the same book. 5, then T6. All right. And then all the other ones, yeah, you were right. I was kind of misaligning those. Those are actually come from a different parts. But after you add the pepperoni, okay, let's go back. So we grate the cheese. That was a different thing. So T2 is grating the cheese. Hopefully I got this in the right spot. 5. And then grating the cheese led to, I just crossed my lines, adding the cheese, right? So that leads to that one because I put adding the cheese as T5. And that's why you want these numbered so you can follow this. I'm just going to have a crisscross, but then my graph is going to be better later because slicing the pepperoni is T3, and that was a source. I'm trying to think of my words here. And that was 8 minutes. I don't know why it's taken so long, but T3. And then that led to adding the pepperoni, which is no, I guess we're okay. T6, no crossing. So I want to make sure I have everything labeled here. And I already have adding the sauce, adding the cheese, and there could be some switches on this on the timing about the pepperoni and the cheese, but not too much. And then turning on the oven. Well, that's where we're going to put this here, because that could have been done at any point, 1 minute. Interesting, it could say warm up the oven. Sometimes it takes longer to warm up the oven, so that should be a different number. And these all lead to the final sync of baking the pizza, which is 40 minutes. And then, because it's hard to write on this, I'm going to get my old drawing of this with better written letters. Actually, I think it's the other teacher's drawing. So, boom. Well, actually, not really. I'm going to use this. There is your directed digraph, whatever. It's just a digraph. Directed graph with all the paths aligned. Then the next thing. This is yesterday's homework. So if you're absent 2 days ago or yesterday, this is what you missed. From a reading, you figure out who the sources and sinks are, and you make a digraph that aligns the situation. And then you find all maximal paths. The first one straight across, isn't it? Source to sink, right, everybody? Now, this is what you got to do on your quiz. Just tell me T1 to T4 to T5 to T6 to T8. And then what you should put next to that is what is the weight, which is actually the time. 40, 50, 54, 64. So this equals 64 minutes. And then find all other maximal paths. See which one is the highest. That is the critical time, which is the minimum that this job could get done. Because the spirit of this is, doesn't matter how many people are working, a task takes that long. And that's what we're sticking with. All right? And that's the idea globally in questions that have meaning. Not cooking pizzas, but building the Hoover Dam. Okay? So get it that this is what we're doing. Why is he yelling? Because he's got anger issues. T2, T5, T6 to T8. And then you just add those up. 40, 49, 54, hike. And then another maximal path. Do we already have the highest, do you think? By the way, yeah. But you're still supposed to find them all. T3, T6, T8, T3, T6. Very hard to write on this. I write better than Lexi Samuelis, honestly. She's a little bit messy, the 9-year-old. 48, 53. I yell at her all the time. Get better penmanship. Why don't you, Dad? Already talking back. All right, and then the last one. Learning from the sisters. T7 to T8. 41 minutes. So, this is the critical time. This is the minimum. This is the minimum that the job could get done. Minimum. All right? And that's what we're shooting for in the next thing, the Gantt chart. Refuse. I don't want to do what I did last year, and I wanted to change it. Okay, here's the graph with a better teacher's writing. The old teacher, Mrs. McGrath, who used to do this. But it's really hard to write on this. But I could have pulled my screen, but I don't want this to. This is a hard copy, and I don't want this to erase when I erase some stuff here if I have to. Okay, so here it is. That's what we had. So now we're going to do what's called the increasing priority list. And this is why writing this in words would do nothing for you. Here's what a Gantt chart is. Number one, what I really want you to do is put a number line down here. A number line is used so that we have a basis. And luckily, because of what happened first hour, I know what I have to do, but I'll talk through it. Don't put any numbers yet. Because now what you can do is start putting a Gantt chart, which is bars, that shows who's working on what task. And I want some scale. And only those that can be really neat are going to be very easily and do very well on this, because it's not really that hard. What an increasing priority list is we're going to have two processors. So let's do this. And on your test, you'll have two processors. By the way, before I continue, if I only have one processor, one worker, this would take exactly all of the minutes that you see here, right? Because they'd have to work on this first. Then they'd have to work on this. And then, oh, maybe they could work on that, but then they'd have to, and then the minutes that you see here, one person, it would take that, all of those minutes, right? Right? So the maximum amount this could take is, I'll do the math for you, 40, 50, 54, 64, 72, 73, 78. Can someone, the maximum time is 78 minutes it would take if that was, if it was just one person, right? 40, 50, 60, 64, 72, 72, 78. The minimum this could take is what? Just to reiterate, what's the minimum? 64. Okay? So, got it? What's going on? Something seems fishy over here. Okay? All right. So, we're going to put two processors. Get up. You're going to fall asleep here shortly. Don't make me kick the thing behind me to wake you up. Okay. Now, here's what happens realistically. What task can I do? Which ones can I do right now? Can I do T8? Come on, everybody. Can I do T8? No. Can I bake the pizza? You don't have anything, so no, you can't. All right? Can I do T6? Can I do T5? Can I do T4? No, and no. So here's what you do. You start assigning these tasks in an increasing priority list. You start with the, hold on, something weird just happened. So these are the tasks that are open. In an increasing, what is increasing? Start what to what? Lower to high. So, all right, we got two people working. What is the smallest number task that is open right now, ready to work on? 1. So, okay, sorry. I forgot to finish this. 78 minutes is the highest that this could be. So my scale down here, I'm going to make this 80. Then I'm going to cut this down to 40. Cut this 40 down to 20. And try to keep my spacing. Oh, I did that first hour too in one of mine. I don't like that spacing. I want to shove it over just a little bit to make it half. Because I want to scale and I want to be able to track how far along we are minutes-wise when I'm comparing these two people working. This is 50 and this is 70. I don't care that I'm going slow. This is allowing my students to keep up. Because now the first one is kind of tough. I'm going to go ahead and assign this task to the first person because it's an increase, small to big. So I'm going to first give the 1 minute task, and that looks like this, even though that's probably a little bit bigger scale-wise than what I have down here. But I just want to give it some sort of frame of reference to my number line down here. And I'm also going to put the name of it. That's T7. And it's going to be so easy to grade when you do this the right way that it'll look great. So now, when I do this task, does that open up this next one? Whoops. What just happened there? That's not the highlighter. Is that the highlighter? Oh, okay. Something weird just happened there that I thought I just saw. I'm freaking out, man. All right, does that open up T8? Yes or no if I do T7? No. That's baking. All you did is turn on the oven. You haven't even made the pizza yet. So what you also have to do is assess to yourself, is this opening up other tasks or not? And the answer is no. So what's the next task that we're going to assign to the second person? They can do T2 while you're going to do T1. And that is 5 minutes. And you can get that to be about half of 10. This gives you about a frame of reference, but you also put the numbers in there and you assign the letters to it. That's T2. And I really think it's a smart thing to cross it off so you don't have to look at it anymore. Now, does this, when they're done with this, open up that task? Yes or no? No. And at this point, I should get rid of these. I was just trying to tell you which ones are open. So when I do this, and even when I'm finishing it, T5 is not open. Now, after P2, not after, but during this, isn't T1 now open after 1 minute? So now T1's open to do something. What is T1 going to be assigned? T3, which is 8 minutes. What does 8 minutes do? It gets you to 9 minutes here, and sometimes you want to do that. You might want to, too. You might want to mark on there that that's at 9 minutes right now, if you can't add 8 plus 1. But it is nice. And I assign T3, and you put it there. So this is how you kind of try to get the tasks aligned as the minutes are ending and the next ones are starting. But wait a minute, doesn't this person open up after 5 minutes? Okay, so now I've assigned T3, which is 8 minutes, and that's not finished yet. But after 5 minutes, this one's finished. But does that mean I could do T4? No, you can't do T4 because you haven't done what yet? T1. Look at the chart. T1's rolling the dough. So we got to actually roll that now, and that's an independent task that needs to be done. So now T1 needs to be done, and that is 10 minutes, which puts us at the 15-minute mark. Is this math? And then this is T1. Okay, but what happens at this point? Well, this person after 9 minutes is open. But here's the problem. Is T4 open yet? T4 is not open. T4 is not open until the 15-minute mark. Can I do T5, T6, or T8? Yes or no? No. So we have to sit here and wait for T1 to be done. Oops. And now T4 is open. But what happens after T4 is open? Can I do T5, or do I have to wait for T4 to be done? I have to wait for T4 to be done, then T5 to be done, then T6, then T8. How many processors do I need for the rest of this process? One, because no task is opened up. Who do I assign it to? We usually assign it to the first person, just to keep things in order. So you do put that this is, and I want to erase this because I confused myself. Okay? Once this got done, now T4 is open, and I'm going to go ahead and assign it to this first person, which puts me to 20. That's why you want the number line here. This is 5 minutes, and now I'm doing T4. No other task is available for person 2 or processor 2 to do because it doesn't get open yet. There's precedence relations. So basically, all you have to do is just keep bumping along and putting 4 here for T5. And then where I'm at right now is 24, even though I'm a little bit off there. Just to keep track of your numbers. And then 5 here is 29, which goes past 30. My scale is awful. I did terrible at this. So I'm going to have to sneak this and go to 29. Always something to say. T6. And then add 40. And at least you know you get to what? 60. Actually, 69. Because remember, this was at 29 minutes right here. 29 plus 40 is 69 minutes. Is this the optimal time, yes or no? Did this match the critical time, yes or no? No. And did you hear that word that I just said? Optimal time. When you do your Gantt chart and you hit the critical time, then it's the optimal schedule that makes this happen. Do you have your phone too? Trying to check those little games? Okay. All right. And then this one, whoopsie daisy. What was that called? The increasing. Let's call this part B. Let's do a decreasing priority list. Let's not, Mr. Samuelis. What does that mean? What does it mean to decrease? Pick the highest open task and go what? Down. Okay, so then what do? You draw a number line. And then we already know that that number line, 80 is a good number because the maximum this could take is, what was it, 78 minutes? I already forgot, Mr. Short-Term Memory. No. What was the largest that this could take? No. 78. That's if there was one person, right? No, okay, you're not missing. No, if you only had one person working, it would take 78 minutes, the add of all those times. Now, if you had 2 or more people working, the optimal time, the time that it could only, it could be no smaller than 64, though. Okay, but so your time is going to be between 64 and 78. Can't be greater than 78. I mean, that's adding up all the times. So anyway, so that's why we picked 80. And then, 20 again. I probably should do this offline. 10. So really what you should find is if there's one person working, what's the maximum it could be, and your number line should probably kind of be around there, even though you are going to be smaller than that. Sorry for the wavy number line. Okay, now again, I don't know how else I can describe this. You have person 1, person 2. I'll call them people instead of processors, doesn't matter. The open tasks are T1, 2, 3, and 7. What's the one I'm going to pick first? In the decreasing, you pick the biggest. They are going to do 10 minutes. Just have a bad angle for looking here, matching that. And they're going to do T1. What am I going to assign to person 2? T3. It's the biggest task that's left over. That's about 8. You don't have to be perfect on your scale. It just gives you an idea. It gives you an idea who gets open next. Okay, so they're going to do that one. Now, after 8 minutes, this task is done. Does that open up T4? Is T4 open in 8 minutes? Yes or no? No, and that's what you just got to, I can't write that in words. But anyway, what would we assign person 2 then, once they're ready after 8 minutes? T2 is open, so we're going to do T2. 8 plus 5 is 13. And if you're not perfect, which I've been far from it, then at least do what I did next, which is, okay, let's keep a note to self that I'm at 13 with processor 2. And they'll snap a little dotted line. The book does this too. So it's a very smart decision. Should I say smart? Okay, now, in 13 minutes, doesn't this person get open, right? And then this one is still going in 13 minutes, but it's not quite done yet. And anyway, what's the only open task after 10 minutes? Well, there's 2, actually. I'm sorry. But after 10 minutes, doesn't that open up T4? So now T4 is open, but also T7. Decreasing priority list, which one should I do, 4 or 7? 4. So now this person gets task 4, which is 5 minutes. 10 plus 5 is now 15, which does show that that's a little bit bigger. So it requires a little precision, a little bit of being careful and making so you know who's open and who's not. All right, and then in that time, here's like 13 minutes. I didn't quite get to T5. All right, in 13 minutes, this person's open. This is going to take 15 minutes. So T5 is not open. So what does person 2 have to do? They have to do T7 now, which is 1 minute. And they're still not. And I forgot to do something. I'm sorry. Forgot to talk about idle time. They talk about idle time. I'll go back to both of them and talk about how much idle time there is for each person. Well, I'm at 14 minutes, and then this person has something to do after 14 minutes, but did T5 open up yet? No, right? And this doesn't open that up, and this doesn't. T5 has to get done before all the rest of them have to be done. Who do we assign the rest of the tasks to? Person 1, or if person 2 has the bigger line, you could go off on them so you make sure. So right here, that is idle time right there. And I'm going to put that with an arrow. There's 1 minute of idle time so far, but then when I assign everything else to the other person, so I'm at 15, this is now 20. Nope. Dang it. Let me go back. T5 is 4 minutes, so this is 19. And then another 5, which is 24. And then what's 24 plus 40? 64. What did we call that? So this is 64 minutes doing it the different way. And again, think about this as a different algorithm. It's a different way of assigning the times. And sure enough, we actually reached the optimal time. Just with 2 processors, we ended up getting what could have happened in the best scenario. The critical time being 64. So what we're saying is this schedule is optimal. It's an optimal schedule. With these 2 people, the decreasing priority list actually hit the critical time, so it's an optimal schedule. So again, think of it as like the repetitive nearest neighbor. They're just a bunch of different tests to try to find a good way to get from one place and then visit 5 others and come back in the shortest time. These two are just two different algorithms to get a schedule that actually is optimal. Does that make sense? We're not doing anything else other than these. There are more in this book that describe different methods. We're not going to do them.